So during the planning and analysis stage, one of the tasks that you have is to determine what type of model you actually need for your data. Now, the type of model that we're going to be doing is the relational, but there are other formats, and so you should be familiar with them so you know when the relational model is most appropriate. And something that's a little bit more simple and less intensive in terms of computing power might actually be better. So there are more data models than just these. These are just the most common ones that you will see. And we're not going to go very in depth with these because we are going to do the relational model. But the hierarchical model is a very simple sort of chart that you've probably seen a lot. This you might recognize looks a lot like a family tree where a simple family tree showing, probably, like just the maternal side because it doesn't have like marriages and all that kind of stuff. This also, an org chart is also another very common use for this. It just shows the relationship between one parent, so the top one, and one or more children, which are the bottom ones. So in what you can see here, the employee is the parent to permanent, contract, etc. Permanent is the parent to software engineer and whatever the thing is on the left. The problem with this type of model is that it doesn't model, like contract can't have two parents. It only goes down. And to actually walk through this, you need to start at the top and go down. So if you can imagine, like my company's org chart actually looks like this, where you have to start at the CEO, go down to like, okay, you want HR, so you select that person, and then you get a drop down of their direct reports, and so you click that person, and then you go down like that. A search function that finds one specific name, if you click on that, it only shows the people directly around them, their direct reports and their parent, so their boss. And to get anywhere else, you have to go up and then back down. You can't, it's not very versatile at all. So it saves a lot of space, like memory. It's very simplistic, easy to use if it's appropriate. But if your data is going to have any more complexity, then it's not going to be any good. Like if you have an organization that has a matrix organization, for example, a hierarchical chart just won't do it for you. A network model is a little bit better. You could have multiple arrows going to the same thing. So you can see here where it has customers, managers, and salesmen all connected to a single order, which you can't do with hierarchical. But it's still limited. In order to do the many-to-many, which you'll learn these terms in a few minutes, but in order to have order connecting to multiple things like that, it's a little more complex to set that up and more intensive on the back end to actually run these. So they're not always great. You'll see them in things like trains and utility networks, but they're just not as common as the relational data model because that's the most versatile. If it's the most appropriate for data, because the relational allows us to be extremely versatile in terms of what concepts relate to each other. And you see that this is mapped the picture is mapped in a little bit different way than the other ones, because you'll often see them laid out as tables like that. But you can have arrows going all over the place, even like circling back to itself in relational tables or relational models. Because it has a primary key, it makes the implementation calling up data extremely fast and simple, much better than the other two options. and you can have true data independence using a relational data model. So the takeaway for this slide, there's multiple ways to skin a cat. The relational is used because it solves a lot of problems. However, it's not always the best. So for example, if it's good for the smaller databases, but it's not always the best for the huge ones. And so there's other options to consider. The mapping process can be very complex for very large databases as well. So there's other solutions out there, but relational is pretty foundational, and you see it in a lot of places. So that's why we're starting with relational database, and you can learn other things in future classes, degrees, I don't know.